Hello viewers, in this session we will discuss about concrete mix design. As we know, we have different methods for concrete mix design like Indian standard mix design. You can refer IS 10262 2009, IRC 44 method, ACI method, arbitrary method, UK method, British method, fineness modulus method, surface area methods. You can choose any one for the concrete mix design. Let us discuss about Indian standard concrete mix design, which is popular as IS mix design for concrete mix. And you have to refer Indian standard 10262 2009. So let us discuss about the steps for Indian standard mix design. First of all, you have to finalize the target mean strength for the concrete mass. As we know, we are concreting in our existing site and we are finding the characteristics compressive strength in our laboratory. So there is a different place and different situation like number of the factors. I am giving you an example like environmental condition, concreting, finishing, curing. So these factors will differ from the laboratories and existing site. So before the starting the mix design, you have to finalize first of all for which grade of the concrete you want to design, and then you have to finalize the target mean strength. So let us discuss about first step, which is target mean strength. So in this case you have to calculate F dash Ck, which is the target mean strength, is equal to FCK plus 1.65 into S. What is F dash Ck? F dash Ck means target mean compressive strength at the end of the 28 days, which is in Newton per mm square. What is FCK? FCK means characteristics compressive strength at the end of the 28 days, which is in Newton per mm square. What is S? S means standard deviation. So you can refer the table which is shown in your screen for the standard deviation which has been given in Indian standard 10262 table 1. For example, I am designing for the M20 grade of the concrete mass. It means my FCK will be 20, then 1.65 into standard deviation. So what about the standard deviation values? So you can refer this table for the standard deviation, and here you can see in this table in the first column you can see the grade of the concrete has been given, and in the second column values of the standard deviation has been given. For example, M10 and M15, the standard deviation value will be 3.5, and M20 and M25, the standard deviation value will be 4. So here we are designing for the M20 grade of the concrete mass. So for the M20 grade of the concrete, you have to take the 4 Newton per mm square of standard deviation. So in this case, you have to put value of the standard deviation in this equation, which is 4.0. It means 20 plus 1.65 into standard deviation value, which is 4. It means you have to design 26.6 Newton per mm square for achieving the 20 Newton per mm square at your existing site. It means when you achieve the compressive strength of the concrete mass minimum at 26.6 Newton per mm square in your laboratories, so you will achieve the 20 Newton per mm square at your existing site. So first of all, you have to finalize the target mean strength. Let us discuss about our second step, which is water cement ratio. Water cement ratio with the different types of the cement and aggregate properties like size of the aggregate, shape of the aggregate, surface texture of the aggregate. You will produce the different compressive strength for the same water cement ratio. So you have to take the ingredients of the concrete mass to be used actually. So here you can see on your screen the table has been given in Indian Standard 456 2000, table number 5. So you have to finalize the maximum water cement ratio with the concrete surface exposure condition. Here you can see in the first column there is a different types of the exposure condition for concrete mass, and here you can see in the second column the maximum water cement ratio has been given in your table. So for the mild exposure surface condition for the concrete mass, you can take up to 0.55 water cement ratio. It means in the mild exposure condition, you can take 55% for the water cement ratio. In the moderate condition, this value will be decreased and you can take up to 0.5. In the severe and very severe condition, both case you can take this value up to 0.45, and in the extreme condition you can take this value up to 0.40. So depending on the exposure condition, you have to finalize the maximum water cement ratio. For example, my concrete has the severe exposure condition. So in that case, I can take the maximum water cement ratio up to 45%. It means my value will not be greater than 0.45. So let us discuss about a relation between water cement ratio and compressive strength. Water cement ratio is directly affect to the compressive strength of the concrete mass, durability of the concrete mass, and workability of the concrete mass. So you can see this graph which has been given in Indian Standard. You can see in the y-axis compressive strength of concrete in Newton per mm square, and in the x-axis we have taken water cement ratio. And you can see with increase the water cement ratio, there will be decrease the compressive strength of the concrete mass. For example, I am taking 0.60 water cement ratio. So in this case, the compressive strength will be approx 19 Newton per mm square. You can refer this curve. For example, I am taking the 0.4 water cement ratio. It means I am taking the 40% for the water cement ratio. In this case, I will get the approx 38 Newton per mm square at the end of the 28 days. So with decreasing the water cement ratio, you will increase the compressive strength of the concrete mass. And when I am increasing the water cement ratio, so there will be decrease the compressive strength of the concrete mass. So water cement ratio is influencing importantly and the compressive strength of the concrete mass. Let us discuss about our next step is calculation of water content. As we know, the water content is influencing with the number of the factors like size of the aggregate, shape of the aggregate, surface texture of the aggregate, and types of the cements, environmental conditions, workability, water cement ratio. So there are the many factors which will affect to the water content for the concrete mix design. And with using the larger size of the aggregate, you can decrease the quantity of the water content compared to the smaller size of the aggregate. And if we talk about the surface texture of the aggregate, so there will be less required for the glassy aggregate compared to the rough texture of the aggregates. So these factors will affect to our water content of mix design. So you can see with the reference of Indian Standard 10262 2009 table 2. Table shows that the maximum water content has been given with the nominal maximum size of aggregate in mm. For example, for the 10 mm, nominal maximum size of the aggregate will require the maximum water content 208 liter, and for the 20 mm, maximum size of the aggregate will require 186 liter, and for the 40 mm, nominal maximum size of aggregate will require 165 liters. So you can see, so with increasing the nominal maximum size of aggregate, you can see there is a decreasing the value of water content in the mixed design. So you have to consider this table for the angular aggregates and 25 to 50 mm slum range. So the water estimate in this table can be increased approximately 10 kilogram for the sub aggregates and 20 kilogram for gravel and with crushed particles and 25 kg for the rounded aggregate. So this table is for the angular aggregates, and in case of you are using the subangular aggregates or the crushed particles or the round aggregates, so you have to correct these values, and this table is for the 25 to 50 mm slum range. If you are using more than the 50 mm slum range like 75 mm or 100 mm, so you have to also correct for these values which has been given in your table. So water estimate in the table can be increased 3% for the every additional of 25 mm slump, and also consider water reducing admixture. So if you are using the 75 mm slump, in that case you have to increase for the value. For example, I am using the 10 mm nominal size of the aggregate, and in that case I have to take the 208 liters water mass, and as we know this value for the 25 to 50 mm slump. For example, we are using the 75 mm slump concrete mass. So in that case, we have to increase 3% of this value. It means 208 liters plus 3% of 208 liters. So if you are using the 100 mm slum range, in that case you have to add 3 plus 3. It means you have to add 6% with this value. So every 25 mm slum range you have to add 3% of values which has been given in your table. And I would like to one more important point which is based on super plasticizer. So if you are using the super plasticizer, so there will be decrease the water requirement up to 20% or above. So in that case you have to correct these values. So our next step is calculation of cement content. After the finalizing the water cement ratio and water content, you can easily calculate by this equation. Water cement ratio is equal to water divided by cement. And as we know, we have a value of water cement ratio and we have water mass. So by this equation, we can easily calculate the content of cement mass. But we have to check this value with the Indian standard criteria. So you can see on this screen the Indian standard 456 2000 table number 5. There has been given the table based on the exposure condition of the concrete mass. You can see the minimum cement content has been given in the Indian standard. For example, the mild steel exposure condition of the concrete, you have to take at least 300 kilogram per meter cube. If you are concreting in the extreme exposure condition, in that case you have to use at least 360 kilogram per meter cube. So you have to consider this minimum criteria which has been given in Indian standard 456 2000, and you can see that second table which has been given in Indian standard 456 2000, table number 6. This table is for the 20 nominal maximum size of the aggregate. If you are using the 10 nominal maximum size of the aggregate, and if you are using the 40 of the nominal maximum size of the aggregate, so you have to correct these values. For example, we are doing the concreting in the mild exposure condition, so there will be required 300 kilogram per meter cube. So this table is for 20 nominal maximum size of the aggregate. For example, we are concreting with the 10 size of the nominal maximum size of the aggregate. In that case, we have to add 40 kilogram per meter cube with these values. So, for the mild condition, the 20 nominal maximum size of the aggregate, we require 300 kilogram per meter cube. For example, we are using the 10 size of the aggregate, so we have to add 340 kilogram per meter cube. And if we are using the 40 size of the aggregate, so we can use 270 kg per meter cube. So based on the exposure condition and size of the nominal maximum size of the aggregate, you have to finalize the cement content. After the finalizing the cement content, you have to calculate the volume of coarse aggregates and fine aggregates. As we know, the 75% of the volume occupied by the aggregates, like the fine aggregates and the coarse aggregates. So aggregates is an essential part in our concrete mix, and you can see in the table which has been given in Indian Standard 10262 2009, table number 3, and you can see this, the first column shows that the nominal maximum size of the aggregate for the 10 20 and 40 and these columns shows that the volume of coarse aggregate per unit of the total aggregate for different zone of fine aggregate. So after the finalizing the zone of the fine aggregate, you have to finalize the volume of coarse aggregate, and after that you can easily calculate volume of fine aggregate. So first of all, you have to finalize the volume of the coarse aggregate with this table. So for example, you are using the 20 nominal size of the aggregates, and you are using the zone 1 fine aggregates. So in that case, you have to use 60 percentage for the coarse aggregate. It means out of the total volume, you have to use the 60 percentage for the coarse aggregate and 40 percentage for the fine aggregate. For example, I am using 10 nominal size of the aggregate. In that case, you have to use 44 percentage for the coarse aggregate and remaining volume for the fine aggregates. So with this table, you can easily finalize the volume of coarse aggregates and fine aggregates. And note down the important point, which is this table is for the water cement for the 50 percentage. It means this table for the water cement ratio is equal to 0.5. For every decrease of the water cement by the 0.5, the coarse aggregate volume may be increased by the 1% to reduce the sand content. And for the every increase of the water cement ratio by 0.5, the coarse aggregate volume may be decreased by the 1% increase the sand content. For example, you are using the 45 percentage of the water cement ratio. It means you decrease the water cement ratio 0.05. In that case, you have to increase the coarse aggregate volume. So you have to increase 0.45 for the coarse aggregate and remaining portion for the fine aggregate. And if you are increase the water cement ratio, for example, you are using the 55 percentage for the water cement ratio. It means you are taking the value of the water cement ratio is equal to 0.55. In that case, you have to decrease the volume of coarse aggregate. In that case, you have to take 0.43. And you have to also do the correction regarding the surface moisture and water absorption for the coarse aggregates and fine aggregates. So after this calculation, you have finalized the volume as well as the mass of the coarse aggregate and the fine aggregate in your concrete mass. Here you can see the flowchart of mixed design. First of all, we have decided the target mean strength. After the finalizing the target mean strength, we have to finalize the water cement ratio. And after the finalizing the water cement ratio, we have to find out the water content for the particular mix. And then we have to calculate the cement content. And after the finalizing the content of the cement mass, then we have to calculate the volume of coarse aggregates and fine aggregates. And then we have to determine the quantity of the water, coarse aggregate, fine aggregate for one bag of the cement mass with the correction of the aggregates like coarse aggregates and fine aggregates. The correction based on the surface moisture and water absorption. And then we can finalize mix proportions for the ingredients of the concrete mass like cement, coarse aggregate, fine aggregates and water mass. Then you have to check the hardened properties of the concrete mass and you have to check that is the strength of the trial mix is adequate. If yes, it means your proportion are okay. Otherwise, you have to do the other trials for finalizing the proportions of the mix design and to achieve the desired strength of the hardened properties. This is the trial based method. So, this is all about the steps for Indian standard mix design or calculation of IS methods. Thank you.